Alright, so I got my console application. I'm going to be working on Lab 16. It says create a debug project called Lab 16. That's fine. This is a project that will allow us to debug, and the first question is, it says create a block of code that creates a vector of integers to represent a deck of cards. Aces and R1s and jacks, queens, kings, and tens or kings are tens. Okay, so I'm going to just make sure that says hello world, sure. So it wants me to make a vector of cards. So the way I do that is I include, like that, this word called vector, and then I make a vector of integers. This is how you would make like a blackjack game or something. You call it cards. Okay, so that will be an array of integers that holds nothing right now. There's nothing in there. And what I'm going to do next is add some numbers to it. The way you can push back numbers onto your list of things is you go cards.pushback, right? And I could just put the number 1 there, and then I'll have in my vector, so let's say I stop it right here and hit this debug button. I should see that my cards, if I go to the watches window up here, I should see that my cards variable has a length of 1, and right now it's just holding the number 1. So then I could so that's like an ace of spades or something like that. And then I could just like keep copying and pasting this. So I could put the 2 of spades, 3 of spades, 4 of spades, all the way up to the jack of spades. And that would be one way to do it, actually. You could also do it in a for loop where you push back. Let me just copy and paste this, okay? So I'm going to copy. I'll put a 3 of spades, a 4 of spades, a 5 of spades, a 6 of spades. I don't really care about the suits right now. I just care about the value of the cards. So for blackjack, you don't care about the suits you have. So there's a 9 and a 10, like that. Okay, so now my cards would have 1 through 10 in them. Hopefully we can see that in the watches window here. There you can see that my cards hold the numbers 1 through 10, which is great. And I actually need a 10 for the jack as well, and for the king, and for the queen. So I'm going to add however many, probably 13, right? Great. So there's 13 cards for my 13 spades. Ace, 2, 3, 4, 5, 6, 7, 8, 9. And ace could be worth 11 too, but we're not cared about that. So I could copy and paste this 4 more times as well. I think I might just do it in a for loop. For int I equals 0. I is less than 4. I'll do it 4 times for each suit. Actually, I is less than 4, and then I plus plus, like that. And I'm going to go boom, like that. And then I'm going to cut and paste her in there like that. So theoretically, I should have 52 cards in my deck, like that. Let's see if it works. Doesn't do anything yet, but if I hit the red play button and put a stop sign here at return, I should see under my watches, a deck of cards with a length of 52. Great. That's how many cards are in a deck, right? Let me zoom in on that a little bit. Length of 52, and they go all the way up. So I'm holding 52 cards in this vector for my blackjack game or whatever I may make. Okay? The problem is they're kind of in the order you would get them in a deck of cards, like ace through king of one suit, then ace through king of the next, and they're not mixed very well. So that's where this algorithm thing comes into play. This question says there is a random shuffle algorithm that takes in a vector and mixes it up. Okay? Create a block of code that creates a vector to represent the cards and then shuffles it. So it looks like I'm just going to copy this line of code, random shuffle, v dot begin and v dot end, after I make my cards in that loop. This command only works if you include an algorithm library though. Algorithm stands for like a list of instructions that the computer can use to solve a problem or do a number of steps. So this is going to be an algorithm that takes in a vector and shuffles it. Now this won't work for me because I'm going to stop it right here. I'll put a stop sign there, yes. Because my vector is not called v, right? So it'll give me an error. V was not declared. My vector is actually called cards. All right, cards.begin and cards.end. And when I do that, I'm going to run it once, and I'm going to stop. It's going to stop it before it shuffles it. So you can see my cards are 1 through 10, 1 through 10, 1 through 10, 1 through 10, like that. And then if I step through the next line and shuffle it, you can see that they all kind of got mixed up. My first card's now a 10, so it could be like a jack, a king, whatever. My second card is a 2, then a 10, and then so this code, this function basically, or command, we don't even really know how it works, but it goes in there and mixes them all up for us. It's kind of a handy thing to have. Or else we'd have to mix them randomly ourselves, and it would be a pain in the butt to do it. So an algorithm is just like a little shortcut to do something, block of code. Okay. There's another algorithm that will sort a vector, which is really nice. So we could actually even sort. Let's get rid of random shuffle and just write sort here. This will sort our cards from highest to lowest, probably. Let's look and see what they do. So I'm going to run the stop sign there. And right now they're 1 through 10 again, just like they were when I made them. And then after sort, so go to the next line, you could see it sorted all 4 1s, then all 4 2s, all 4 3s, and then all the 10s are at the end. Okay? So that's kind of the power of the algorithm. Okay. Because sorting them would be a lot of code for us, right? Here's another one. It says there's a function called isSorted, and it actually returns a value if your vector is sorted. So let's write isSorted like that. Make sure it turns green. Okay. And instead of just putting it on the screen or writing the code, we could actually see out it and see what happens. It will tell us if our vector is sorted. It writes 0 on the screen, so that means it's not sorted. Okay, so it can actually check if it's sorted too. So that's another question that we might want to answer. It says create a vector that holds 100,000 integers and displays the largest element using the max element algorithm. Okay, let's do that. So I'm going to make a vector here after my cards that will hold 100,000 random numbers. So I'll write vector like this, and it's going to hold in integers, and I'll just call it, nums or something like that. Okay, and then I'm going to go and make a for loop that runs 100,000 times. Like that. And I'm going to say nums dot push back. And how do you put back random numbers? You just write rand in percentage sign like that. Okay. Will it run? Yeah, it ran. Nice. Sometimes it's not going to mix up our random numbers. Remember, if we want to mix up our random numbers, we have to go srand and then write the word time 0. Well, let us do that. It's never heard of time. So to get time to work, we have to include it. This is kind of the cheeky way to make random numbers. It's not the best way, but it's good enough for our purposes, right? Include time. Okay, so this should make a random variable with 100,000 entries. If I look in the watches window here, right up here, I should be able to see that, yes, it's got 100,000 in there. It won't show us all of them, the first 200. Do you see them all there? Okay. Cool. So what does it want us to do? It wants us to find the max element. So let's C out, and I believe the command is max element. And it's going to take in, again, just the beginning, nums.begin, just like all the other ones, comma, nums dot end, like that. And it will tell us which one was the biggest. My cap lock's pressed here for some reason. There's one little small problem with this. I think this actually returns the actual element. So if you want it to print out, it returns what number of element it's at. If you want to print out what the actual number is, you have to put a star there. It's one of those awkward circumstances in C++ where you have to actually put a star there. Okay, so run that, and it will tell us the biggest one was 32767, which, let's say I put 100 numbers only instead of 100,000, like that. The chances that it are, look, at the biggest number it found was 32,174, so it didn't find the biggest number that a random number can be, 32,637. Each time it's a little different. 32,301. 32,490. It looks like it's going to be close to 32,000, but the more numbers I add to my list, the higher the chance I have of actually hitting the biggest number. If I add 1,000, it's 32627. Now it's 32655. But if I add 100,000, I have a really good chance of hitting that biggest number. Every time I run it, I'll probably get 32676. Not guaranteed, but it's just randomly going through all the numbers, right? So if I run 100,000 of them, I have a pretty good shot of hitting it. Sometimes I don't. I probably won't hit it, but whatever. Okay? So that's how I find the max element in a list using those algorithms. There's one other question that wants me to find how many times it actually occurs. It wants me to use the count algorithm. Okay, so how do I use that? I'm going to C out count like that. Again, I'm going to put in nums.begin like that, the brackets, nums.end like that, and then it wants the actual value that I'm looking for, which is going to be this crazy number right here. So I'm going to copy this whole max element thing and put it right there like that. And then that should print out how many times it actually occurred. So for me, it occurred 3 times there. If I run it again, it occurred 6 times. If I run it again, twice. If I run it again, 3 times. If I run it again, once. I got lucky there, or it hit it once. If I do 1,000,000, I'll probably hit it more times, right? Now I hit it 37 times, 18 times, 29 times. That's definitely the biggest number, 32768. Okay. 29 times, you get the idea. So that is how you finish that lab. So work on that today.